Hey, thank you very much. It's a great pleasure to be here. And you learn so much during the conference that you have to pretty much scrap your whole presentation and present it a little differently. So that's what I'm going to do. I'm leave the notes aside and hope we can get it done that way. So I'm going to talk about blockchain technology and something called the emergent engineer tech sector. And I'm the founder of the Integrated Engineering Blockchain Consortium. You'll probably understand that title a little bit more as we go along. And I'm working with Matt Bowers, who's over here, and he approached me for this contest, and we put together the abstract, and here we are. It's a great opportunity. So how many people have heard of Bitcoin? A lot of people. How many have heard of blockchain? Almost as many. By far the most important thing, the most interesting thing is blockchain. Bitcoin, we're going to be using that as an example for how these things work, but the most important element is the blockchain itself. So we're going to be focusing on that. But for some fun facts here, the cryptocurrency market capitalization, that's all the different cryptocurrencies, including Bitcoin, is at $100 billion. Bitcoin today, last night, you could buy one for $2,720. It's just a mass of electrons that you're buying for this phenomenal quantity. If you bought $100 worth of Bitcoin in 2010, it'd be worth about $60 million today. So people are paying attention to this. The Fintech industry is basically financial companies involved with technology, which encapsulates this technology here. They've invested $2 to $3 billion in studying how this would work in their industry. InsurTech is catching up at about $1 billion. Startup VC funding is about $500 million, and I'm probably one of the only people in engineering talking about this. So we've not paid very much attention to it at all. So what is Bitcoin? Well, Bitcoin is a peer-to-peer payment system that operates with no centralized authority. See, right now, you have to use a bank to transfer money. I mean, it's even faster to send $100 by FedEx than it is to do a bank transfer, because you have that third party is always involved. But now you can do that with no centralized authority and instantaneously. So the interesting part is blockchain. Blockchains are the fundamentally different architecture of database that allows these types of transactions to occur. And they're characterized by many people able to write to the same database. And they don't have to trust each other because all that is managed by cryptography. So it keeps me from giving myself a raise or changing conditions of a contract, because there's certain cryptographic tools which restrict that. What problem does blockchain solve? It basically solves the handshake problem. So it's like an escrow account. So in the old days, if I have a contract with Matt and I send him a valid contract over email, he opens the contract, he's got a valid copy, but I still have one on my hard drive. I can change the conditions. I can make 100 copies and put all over the internet, and there's no way to verify or know which is the valid contract. Okay, because computers are really good at copying stuff. They're not really good at this sort of thing. In fact, it's very, very difficult for a computer to do that. With blockchain technology, you can be assured that I send him a contract, and by the time he gets it, he will have the only valid copy. So let me talk about how this is done. It's really, right now I can hand him a contract and he has the only valid copy. That's a very human transaction, but it takes a lot for a computer to imitate a human. So here's this dance that a computer has to do to achieve that very same thing as me putting a contract on his desk and him having the only valid copy. So what the computer does is it creates these vaults. Okay, it's very easy for computers to lock things inside databases. And then it applies these three rules. The combination for each of these vaults is stored in the prior vault. Okay? Each combination can only be used once, and no two lockers can be opened at the same time. Okay, so that means you have to open this one, get the combination, open that one, throw away the combination, close that door before this one will open. And that's what keeps the thing moving forward. It can only move forward, it could never move backwards. In fact, it would cost more money to move it backwards than any sort of hack that you would be trying to steal. So this is how the blockchain is a chain of vaults. So ignore this really quick for a minute, I'll talk about that in a minute. What blockchain does, instead of putting the combination inside the vault, the Bitcoin protocol issues this little puzzle. And it's very difficult to solve, but it's very easy to verify that it has been solved. And then there's a whole group of people called miners who are out there solving this math puzzle with powerful computers. And whoever solves a puzzle is given a whole handful of Bitcoin, a lot of Bitcoin. So you can never tell who exactly is going to solve the puzzle, so you can't corrupt them to find out, to hack this system. And there's so many people doing it that no one single person can take control of this process. And this is what keeps it decentralized. This is how it's allowed to go by itself. Now it turns out that this is very, very useful, these vaults, for putting these contracts. So there's a whole group of people who are out there putting contracts inside these vaults, executing contracts like escrow documents or sales documents or sorts of things. And then there's an independent group over here who's actually pushing the thing along. It's like an irreversible pump, and then Bitcoin is the energy which pushes this thing along. So Bitcoin has to have value, otherwise there would be no motivation to solve these puzzles. If it loses value entirely, then that's kind of the equivalent of a bankruptcy. But they have a lot of value, so there's a lot of motivation to solve these puzzles, and this is how Bitcoin works. So if you look at this long enough, you start asking yourself, well, what if we can use real-life engineering puzzles to solve and create these blocks and to create that coin? And this kind of looks like a work statement or any sort of sequential process. And we encounter those in engineering all the time. Work statements, forensic investigations, all sorts of stuff. So this starts looking like something that could be extremely useful in engineering. To be able to put observations in the vaults and close them. It's kind of like our PE stamp. Once it's sealed, it's sealed. Okay, it's registered. It can't be hacked. It can't be changed. So you start seeing a lot of similarities between what we do as engineers, what our stamp can actually accomplish, and this blockchain technology thing. So this causes us to look a little further at it. So what is the value of engineering in the financial system? So we have to find out where is our value? How is it registered now in the world? Well, there's this virtuous circle between engineering, finance, and insurance. So if a bank will not lend money to a project, it cannot be insured. And a project cannot be insured unless engineering is done correctly. And you can't do the engineering because you need money for without finance, because you need upfront costs to pay for all the soft costs. Okay, so it's like this virtuous circle. Now, one of the problems in finance is that all securities must be backed by some form of collateral. Otherwise, the security ceases to exist. We saw that happen with the 2008 financial crisis when the collateral of the mortgages were divorced from the underlying security, and the whole system almost came down. So engineers serve a very important part because we are the ones who are securing that collateral. All those buildings, bridges, and highways and so forth. Insurance is another thing. This surprised me a lot. They don't really care about risk. They only care that the risk is priced correctly. So the fundamental job of insurance is to even out cash flows. So who's out there mitigating all that risk? Again, it's the engineers. So this is what we have to look at in terms of the value, how we value engineering in society. Now, if you look at the blockchain again, the roles of engineering are that we make a claim or we verify a claim. And these are some of the things, some of the claims we make or some of the things we verify. Each and every one of these is a contract that can go onto a blockchain. It can be executed on a blockchain. Okay, so we can see the input to this essential system of finance, and we can see how we go into it, and we can see the value is transformative. So that building can't be occupied until the certificate of occupancy is issued, or until that permit is issued. So we've got a very transformational part in the economy. Future roles are going to be even more dramatic. We've got the blockchain itself is built by engineers. So how do you secure the blockchain? Well, you got to secure the engineers, not just the licensed ones. So you need some way to secure all the engineers. The Internet of Things is an idea that you could put sensors on everything, and you could upload those to the internet. But who's going to design the sensor, isolate the sensor, maintain the sensor, verify whether it's operating correctly, or those sorts of things? You need to have some engineering in that system. You see some adjudication. Artificial intelligence is another one. We're working with IBM, and they've got this amazing thing called Watson. It's amazing what this thing can do, but it needs to calibrate itself. to a known set of experts. Where are those experts? Who are those experts? How do you find them? It's still a big question in AI. So every one of autonomous vehicles is another one. Now BIM and computer engineering, these are huge models of information that have to be stored somewhere, have to be verified. So how are we going to do this? So the future is digital, and engineers live in an analog world. We need a better way to organize ourselves so that we can do our job better, and we need a better way to measure our value. I guess one of the stories is a fireman doesn't really have a lot of value until there's a fire, and then they're worth $1 million an hour in saving lives. But the engineer designs the fire system, and there's never a fire. So, how do you measure the engineering? The fireman is measured by the value of the fire, but if there is no fire, then the engineer has no value. There's no way to value that engineer. So it's sort of a problem that we have. But what if we had a digital presence and that we could measure our value and we could inject that into the financial system? What would these tokens be worth? Okay, so here is quant. Quant is a word I made up, but it's a currency. It's a cryptographic coin, very similar to Bitcoin. So I'm going to explain this very similar to Bitcoin. The objective is to create the simple autonomous blockchain with a proof-of-stake algorithm, which is very similar to the proof-of-work algorithm. I can explain the differences later. That uses engineering puzzles to create these blocks and to mine these electronic tokens called quant. And those are the things that power this blockchain. So there's two ways of there's two inputs to this system. I make a claim and I verify the claim. And let me show you how that works. So the basic operation is an engineer would make a claim about their examination or their education, their experience, or the puzzles that they've solved, the contracts they've executed. And when they put that onto the blockchain, they're awarded quant by the software, which are these digital tokens. Another engineer comes along and verifies this claim, and they too are awarded quant. But at this point, now they become joined in a network. So now Matt and I are joined in this network. So the amount of quant awarded is proportional to the reputation of the engineer. And their reputation is calculated from this transaction record. So the transaction record is mined for very, very useful data. It serves as a unique identifier for the engineer without exposing their name. It serves as a certification system to see what they've actually done and been verified in. And the accumulation of all engineers in a database, all their transaction records, this represents the body of knowledge for the engineering profession. And it's in a format which can be mined with great utility. So what's going to happen is, in order to access the network, you need to purchase the quant from the individuals who own the quant, and those are going to be you, the engineers who mined it. So now you would have banks, insurance companies, contractors, municipalities. They're going to hoard quant in anticipation of the future use of engineering. In fact, they're going to try to hoard it, and the price is going to go up. As the price goes up, more engineers are going to jump into the system and bring the price down. But what happens then is the system becomes, it functions as a network. So the value of the system is proportional to the number of people in it. So this is how it balances, okay? It sort of balances itself. That's sort of the fiscal part of how this thing would work. But what does it accomplish? Well, the transaction record serves as a certification for all engineers, not just the licensed ones. Okay? It creates an identity system without revealing your actual identity. You would reveal that at the point of transaction. You're actually one-to-one with somebody. So the combined TRs create an engineering book of knowledge. Now, quant measures engineering value because the exchange rate between the quant and the dollar is going to find some level. And that level is going to represent engineering value. Okay? You have two currencies. One, the dollar represents all of human productivity. It's represented by a dollar. Well, the quant is represented by all of engineering productivity, which is also a proxy for public productivity because we design all the roads, bridges, highways, and infrastructure. So those two currencies should enjoy liquidity because they're being represented by the same underlying asset, which is productivity. So the data can be mined for business intelligence. It also provides a path to PEs who they can engage in the economic system without necessarily being PEs, but they're awarded so much more for being a PE, it provides a path. And there's certain problems in our profession now which there's very few incentives for young engineers to seek this path. Now, forgery is impossible because if I was to copy, if I wanted to gain access to a nuclear site, I need to have a transaction record which reflects that knowledge. So I would have to go back in time, which you can't do in a blockchain. So there's no way for me to construct a forged identity because it's all modeled and set in time. And it's all verified by other engineers. I have to corrupt a lot of engineers over a long period of time in order to get this access to this facility. So the probability of that happening is extremely low, possibly exceeding the value of the thing you're trying to attack. So what happens now, this is interesting. Right now engineers we're all sort of organized in hierarchies. And this makes a lot of sense in the old days for allocating resources and for the division of responsibility, or the separation of responsibility. We form these hierarchies, and that's served us very well for many years. But the value of a hierarchy is a linear function, which is dominated by RM, which is market risk or market return. So depending on the product you make and its performance in the market is the value of your company. However, a network of engineers, any kind of network, is modeled by a different equation, which is proportional to the square of the number of nodes in that network. So the value of a network, as it grows exponentially. Okay, so this is going to be the dominant force on the thing, bringing it up in value, the size of our network. That's the obligatory equation for an engineering presentation. So if there's any doubt in your mind that this is worth something, you look at Airbnb, you look at Uber, Google, Amazon, they're all modeled as networks. The size of their network makes them impenetrable. It's not their CAPM. Okay, now these companies, Amazon's building rockets now. These companies are just swallowing industry after industry after industry, and if we think for a minute that we're not vulnerable, then we're going to be very surprised at the speed and veracity that somebody is going to do this for us, because the utility is so high, the productivity is so high in our profession. It's a very tempting target. So our choice is we have to either disrupt ourselves or let somebody disrupt us for ourselves. And I don't think the second is an option, is a conversation I'm particularly interested in. So the technology exists today. Steemit, for example, I can show you how this exact functionality works today on a living, breathing blockchain. It's not a mystery. Steemit, you wouldn't even know you're on a blockchain. Steemit did not exist 14 months ago. Today it's got a valuation of $500 million. That's how fast this stuff is moving. It doesn't make sense that currency or Bitcoin should be worth $2,700, because we're going to create a currency which has actual intrinsic value, and we're going to see what that's worth. Okay, so Steemit exists. It comes from the BitShares ecosystem. EOS is the next iteration of that. This is being done by Cryptonomics, and they're on our board of advisors. We've known them for years, so we know how to do this. We also, I wrote a couple of white papers. In 2015, I headed the NSPE task force for the National Society of Professional Engineers, and we wrote a white paper on this stuff, and we came up with a couple of conclusions that cryptocurrencies, as they exist, can neither be treated as money nor property with existing laws. But a PE license, we establish law. We can validate property. We can validate values, establish property. So PE holds an asset in suspension, so the PE can hold a cryptocurrency in suspension as an asset. So that's the conclusion of that report. A sister report we wrote was for the National Association of Insurance Commissioners for the Center of Insurance Policy and Research. So the insurance commissioners are appointed by the governors of the states. So this is a pretty influential group, important group. And the paper that they published of ours was that it came to the conclusion that insurability may break down when you're claiming economic loss of cryptocurrencies, because they can't be treated as money or property. So how do you compensate for the loss of one? You can't restore somebody's Bitcoin. You have to somehow restore the economic value, and there's no laws that are making that available. Now the solution is that an insurance product combining the PE with blockchain fulfills the conditions of insurability. So we sealed that hole. Okay, so now that virtuous circle is intact. It really, really looks like we can do this really quickly, and there's just nothing stopping us. Blockchain technology can serve as an engineering operating system. And you're trying to wrap your head around that. So we would put the things that we do on a blockchain, creates this indelible record It cannot be hacked, cannot be reversed. There's a lot of implications to that, and we can deep dive in other parts of this event. The tokens measure true value of engineering into digital existence. Right now, there's no way to measure true value of engineering, so we're all paid the minimum that the market will give us. Whereas if we were to understand what the true value of what we do is, then the compensation models could change, maybe to a percentage of the product, percentage of the value sort of thing, like most other professions. There is no reason why we cannot do this. The only reason why we can't do this is because we're not able to organize. Okay, and this is a problem that I've had a lot of. We're segmented by our silos, by our states, by our state laws, by our profession. We're exclusion of other parts. So we're not operating as a network. And the longer we're separated, the longer that we're segmented, the harder it's going to be to form a network. So there is no urgency in the engineering profession to see when this train is barreling down the road. I found very, very little urgency. So this is the sort of thing that we're trying to get moving. And nobody's going to do it for us. They're going to do it to us. They're not going to do it for us. I mean, autonomous vehicles are being developed in private. You know, they're not consulting with traffic engineers on how to build these things. And the NSPE has a big argument about this. And hey, you got to talk to us. We'll show you how to do it. We'll put sensors in the road. What do you need? Talk to us. But they're competitively in private. So this is what's going to happen: is eventually, you know, all this stuff is going to be done by very powerful platforms in private, and our input's not going to be accepted unless we put it in a format that can be understood. So the questions, there's probably a lot of them. I hope there's a lot of them. So please, if you want, you can write them on paper that you have and give them to me. Give me your email if you want written responses. And check the box if you want to be on the Integrated Engineering Blockchain Consortium mailing list. And so what do we have? Any thoughts?
Get past the dazed look in the eyes. Yeah. Okay, go ahead.
Okay. So, you know, one of the things we've always complained about is that the true value we bring to a project is not measurable, because if we do more work, we can reduce the cost of the asset or make the asset more efficient.
Absolutely.
How does that come into play when you do your circle there?
Well, the idea here is that we're not invading on the way you do things already. This is sort of a layer on top of everything. Okay, so what you do now, you get paid in dollars, you work in dollars. That's going to be, nothing's going to change. Okay, so what happens is the information, when you do a project like that, the information, all the things that you do on that project are documented, placed on a blockchain, and you receive quant in exchange for it, and other people verify your quant. So you're incented to do the extra work because this quant is going to have value, and you're going to be paid by the network.
Because the project is more efficient, the value is going to go up, and the verification will pay you.
Well, there's a lot of things you can do now, because like a blockchain can issue micropayments. Or a bank, you can't go to a bank and say, you know, transfer $1 to this guy. It costs more for a bank to do that than the value. So you can have a sensor, for example. You can put a condition in your contract. I'll do this extra work if you let me put a sensor in this thing, and every time the system works correctly, it sends me $1. And for eternity. So you're constantly receiving. So you can start getting onto different compensation models. Like an architect would solve that problem by simply charging a percentage of the fee, you know, percentage of the project. All brokers do that too. Real estate broker takes 6%. You take 3% to design a building.
So if you designed a building that had a lower efficiency rating and a higher efficiency rating and used less electricity, you could get a little piece of that every time it got a little
Yes,
less.
you negotiate that yourself, or they realize this building is better than that one, so you're the person they seek out. So your secret sauce of the things that are between your ears are kind of registered here. So they would seek you out, or people near you in your network, or that sort of thing. So, and they would pay quant to do that.
What?
Oh, sorry. Yes, sir.
What about regulatory constraints? Okay, this is a person-to-person, excuse me, possible regulatory constraints. This is an exchange,
right,
of something of economic value,
right,
between one or more parties.
Right.
Okay. Historically, that activity has found itself regulated.
Correct.
by various entities in
Securities-
various ways.
The Securities and Exchange
So
Commission.
what about that?
Well, yes, the Securities and Exchange Commission regulates securities. Okay, so there's something called the Howey test, and you run through the Howey test and you test your issue against that, and it tells you, yes, you're violating law, no, you're not. So most of these cryptocurrencies, they're really not selling anything. There's nothing really attached to that. They're collecting all these money in their ICOs. We're going to do an ICO, which is called a initial coin offering. So they're going to probably get slapped by the SEC at some point. However, we're not selling an equity. We're selling a subscription, an access to a database. And this is done all the time. This is nothing new about that. So we're selling access to a database. In fact, we're pre-selling access to a database. I mean, if that were the problem, then, I mean, United Airlines would be going to prison because it's frequent flyer miles. That's what it is. It's not the security. And this is what keeps us out of trouble, because it's not security. We have where we are. Our instrument is valid.
Okay, now, follow-up question about terminology. You said engineer enters his information.
Right.
And in return receives quant.
Correct, yeah.
Then you said after that, then someone else comes along and verifies the quant.
Correct.
You mean
Validates-
that he verifies the information?
Right, right.
Okay.
So they validate you. If I put too many claims that are unvalidated, I look like fake news, right? There's no validation on this. What are you talking about? So people are going to see that in my transaction record. It's not going to look good. Or if I have put something up and some guy I don't know tries to validate me and he's not even an engineer, I could reject that. And having too many rejected validation offers doesn't look good either. So there's no incentive to cheat. So it's actually an incentive to know the person a little bit more than just a casual relationship. So because you're going to be put together in a network, you're going to be linked to that claim, both of you.
Who owns the code? Who updates the code? Who operates that?
Well, the code is there's going to be I guess we'll take a this is like the fiscal part of this, and we'll have to figure all this out. But there's ways to extract a percentage for the maintenance of the system.
No, I was thinking about gaming the system.
Well, you could try, but Steam hasn't been gamed yet. So we've got a living, working example. It hasn't been beaten yet. So, yes, sir.
So has any other profession considered this? Medical profession or what?
Well, no. Not that. Well, yeah. Well, a lot of people. Okay, so there's a lot of different blockchains out there, and they represent certain other activities. Like the movie industry is using it for rights, rights management, or artists that have rights management. It's like a poor man's patent. You put it on a blockchain, it's immutable. The thing that we have that's different than everybody else is we are outside of the UCC. We have our own separate law. Okay, and this is our superpower when it comes to this kind of stuff. The PE itself. This is why we want to start with the PEs, and then the chartered engineers in the UK and so forth, and then eventually expand to other engineering professions. But we have an established law which allows us to do certain things that no other profession can. We just don't know it. We have no idea how to exploit that, and I believe now we can. Yes, sir.
I have a question related to two different ends.
Yes.
One is, how is my work being established? By what criteria? Who designs that criteria? Why do I earn more quants than he does for who I am? That's one question. And the next question is, if I design a building that is much more efficient than he designs, how would that be known? Is it like now people write about the hotel experience was good? Would our clients write on the website or somewhere that we designed a building that is more efficient? And how long does it take for anybody to understand that that building is more efficient and to benefit me so I get more quants?
Okay, so there's several projects that we're working with. One is at Stanford University called the Real Estate Operating System. This is the second question. And what they're doing is they're collecting all of the information from a building, from design, construction, to demolition, and they're putting it on a blockchain. And their slogan is, you can't make a smart city unless your building has a memory. So everything that happens to that building, every engagement, everything sold, goes on a blockchain about that building. And the idea is to make the market more efficient. Sort of like Carfax. Remember when you used to buy a car and it would lose a third of its value as soon as you drove it off the lot? But then Carfax came along and added a few little bits of information, and now a car retains 80% of its value for a couple of years, because that information made the market more efficient for automobiles. Now you can get insurance and you can capitalize on an older car. Kind of the same thing with buildings. Like a building would have a true value because it's got the information about it. So it's not being valued mark to market, what the next billionaire will pay. It's valued to the condition it's in, how it's held up, and the energy it uses, energy it saves. So that will be an example of how your effort will become a public record. Now, the exchange rate for quant against the dollar is a little bit dicier, and that's going to be more, again, on the fiscal side, how these things level. So one thing you could do, and we've thought about many things, here's one thing. If you put too much information, then you're kind of leaving money on the table. If you don't put enough information, then it's not a very good thing to validate. So you have to kind of find the right amount of time you're going to invest to receive a certain amount of quant. And your reputation has all these other things that you've done, so it's going to be based on your reputation initially. However, there's a lot of ambiguity, as you said, in what generates these coins. And one way of doing it would be to have an insurance product, because a claim is an insurable event, and a validation is an insurable event. So you have an insurance product that says, say I'll validate a piping system, and I'll charge you $1,000 to do it, and if I'm wrong, I'll give you $20,000. And then you have a reinsurer who's willing to take that bet. Now they can take that bet because they've got all the data that they need to do it. So now you've got a business of validating these systems. So what happens is the price of the premium is going to reflect the risk. So your difference between the dollar and the quant is going to be proportional to the risk premium, the premium on the risk. Okay, so that's kind of that's one way of doing it. That'll level everything out. That'll level all the cash flows out. So there's a lot of things we can do once we have the data in the right format. And it's a matter of getting the data in the right format.
I'll take one last question here.
Yes.
And I'll let everybody else connect afterward, okay?
So let's say everybody today decides to join this network and has their PEs and represented, and you said you plug in all your information. So somebody who has 30 years of experience plugs in a bunch of information, but somebody who's a young engineer like myself would just plug in a little bit. But you said you want it all to be verified. So what's to keep somebody who has 30 years of experience to be shown as more reputable than somebody who just started out, and showing that knowledge base, because you can't necessarily verify a project that somebody did 25 years ago.
Well,
so how would you roll it out efficiently to show certain things being represented properly of Asian experience?
Okay, so this morning we saw at Northrop Grumman how they were able to manipulate that data and make color charts and stuff out of it. It'll be kind of the same thing. But to answer your question more directly, if you have an older person who's got all this experience, he's got very few people who can verify because they've traveled or they've passed away or moved on, something like that. And they need a young person to verify. So you can earn money for verifying the work of an older person. So if they're your teacher, they teach you something, they make a claim on that teaching, you make a claim that you learned something to verify that, and you can generate quant this way. Okay, at some point it'll be more profitable for the older gentleman or female or the engineer to have many students and to teach them, because they're going to get, it's a quick and fast way for them to get verifications and to get to expose their knowledge. But they only can do that if there's younger persons who are willing to learn that stuff. So it incents a collaborative environment, a teacher learning event. And we actually have a development, a user interface for this speaks to that question directly. And if you want, I'll send you, I have a video, I'll send it to you.
Yeah, because I mean, I can just see if everybody in this room decides to do it initially, it'd be more incentivized for a younger engineer to do it who still has, 20, 30 years of experience ahead of him to build up, but somebody who might have 5 years left in their career before they'd like to retire isn't incentivized, but that older person is obviously has a lot more draw that industry needs.
We'd want you to game the system, in fact, to answer your question. Not hack it, but game it. Find the incentives and use those incentives to your advantage. Okay.
Okay, we're going to stop with that. Thank you.